These are Algebra Notes 4.3 on writing systems of equations from a graph or a table. Now, here's the thing, guys. We have been writing equations by looking at graphs and tables all along. It just, when we're doing a system of equations, it just means we're going to do it twice. So you know how to write equations by looking at a table. Remember, when we write an equation, the two things we're always looking for is the slope and the y-intercept. If we can find the slope and the y-intercept, we can write an equation. So it's not going to be hard. Let's take a look. First of all, it says here, scientists studied the weights of 2 alligators over a period of 12 months. Use the tables below to determine the initial weight and the rate of growth for alligator 1 and alligator 2. Now, look, guys, anytime you start seeing something about a rate of change, a rate of growth, we're talking about the slope. If we can figure out the rate of growth, we got the slope. And the y-intercept is always where we start. So if we can figure out the initial weight, that's going to be your y-intercept. So let's take a look here. It says, what is the initial weight of alligator 1 and alligator 2? Well, alligator 1, at 0 months, he was 4 pounds. Alligator 2, 6 pounds. So what does the initial rate represent? That would be the y-intercept, or the weight when he was born, right? It's at the starting weight. It's the starting weight. Okay? Now, what is the growth rate per month of alligator 1 and alligator 2? Well, let's look. Alligator 1. From 0 to 1 month, he went up 1.5. From 1 month to 2 months, he went up 1.5. And here, 1.5. And all of these are going up by 1, 1, 1. So the rate of growth is 1.5 pounds per month. For alligator 2, these are all going up by 1s. And these are always going up by 1. So his is 1 pound per month. So the growth rate, what does that represent? That represents the slope in this situation. So use the information and above and define the variables. So how about we use x equals the number of months and y equals the weight. Now, a little clue on why I picked those was looky. Here it says time in months, and it's right there on the x-axis. Here it says weight, bada bing, bada boom, right there on the y-axis. Okay, now we need to write the equations for alligator 1 and 2. Well, we have our slopes, which is the growth rate, and we have the y-intercepts, which is the starting weight. So let's go ahead and write for alligator 1 is going to be y equals 1.5x plus 4. And old number 2 alligator is going to be y equals x plus 6. Because it needs to be 1, and that's 1x right there. We don't see the 1 in front of it, but there it is. There's your two equations. Now, sorry, I'm kind of yawning. Okay, now it says to graph them. So remember, when we graph, we always start with the y-intercept and then use the slope. So on this one, let's look at alligator 1. Instead of using the slope, I'm going to use 2 perfect points. Look, here's this y-intercept is 4, and then at month 2 it's at 7, so I'm going to go up there because that one's easy to plot. And guess what? At month 4 it's going to be 10. So let's go up here and do 4, 10. You get some nice perfect points. It's a lot easier to graph. Oops, didn't do that very well. like that. And that's number 1 alligator. Now let's do the second one. We're going to start at the y-intercept, which is 6. And on this one, all of the points are perfect. So we have 1 and 7, 2 and 8, 3 and 9, 4 and 10, 5 and 11, like that. It's just going to go straight up. Bam! So there's our graph. Now, I know it doesn't ask this, but, oh yes it does. It does ask it. What is the solution to this, and what does that solution mean? Now remember, on Monday when we learned about solutions, solutions are where the two lines intersect. So this is where the lines intersect. They intersect at 4, 10. Well, what does that represent? Well, it just means that when the alligators were 4 months old, they were both 10 pounds. That's the time when both alligators weighed exactly the same amount in weight and at the same time. So at 4 months, they both weighed 10 pounds. Okay, let's go to the back. Okay, it says the charges for 2 satellite radio services are shown in the tables below. And then it asks us some questions that we're going to fill out, and then we're going to go ahead and write the system of equations. So remember, I can pretty much guess that we're going to be finding the slope and the y-intercept, because those are the two things we need when we're writing equations. So let's take a look at what it asks us here. It says, what is the initial cost of each service? That means, what was the cost at the beginning? Well, we're going to have to look and see. On radio service 1, this is going up by 10, by 10, by 10. So if we want to get to the first one, we're going to have to go backwards. So let's subtract 10, and we get 20. So at 0 months, it's 20. So $20. Then on this one, it's going up by 11, by 11, by 11. So let's go backwards 11, and we end up at 15. Now, what does that represent in our situation? The beginning cost is going to be the y-intercept. Now, what is the rate or the cost per month for each service? Well, we've already kind of figured that out because we needed to know it before we worked backwards. So here's the cost per month for Radio 1, $10 per month. And on the second one, it's $11 per month. Now, write a system of equations that represents the function. So remember, we need the slope and the y-intercept to write our equations. So I think you could do this. Hit pause, write the two equations. Then you can check your work in just a minute. Okay, so I hope what you have written down is y equals 10x plus 20 for radio service 1, and y equals 11x plus 15 for radio service number 2. Okay, let's go down to number 8. Okay, it says the table shows the height h of 2 trees that were planted in the same year. Both trees grow at a constant rate. What is the system of equations that models this situation? So it's telling us here the height is h. And we can look in the equations, and they're using t for time. So here's the t. This would be kind of like the x in a normal equation, and the h would be kind of like a y. So let's see what we can figure out. So first thing we want to do, I'm gonna put 2 lines here. Tree 1, tree 2. Let's see if we can write 2 equations. Let's start with tree 1. Tree 1, look, at 0 years. When it was first planted, it was 3 feet high. So there we go, there's that. And then what's the change or the rate by which the tree is growing from year to year? Well, it's growing 1.5 feet. 1.5. So 1.5. Check it here, 1.5. 1.5. So here's the initial height, here's the rate. So we would say y, whoops, not y, in this one, h equals 1.5 t plus 3. Because we're using our slope, or the rate of change, which is 1.5, and the y-intercept, which is 3. Okay, now let's do the second tree. It has an initial height of 6. So that's going to be your y-intercept. And what's the growth rate on it? It's going up plus 1, plus 1, plus 1 foot every year. So let's write that as an equation, because we have our slope and our y-intercept would be h is equal to t plus 6. So let's find an equation that matches. And I think if you look, it's going to be letter D. Okay, so on number 9, we're going to look at the graph. And it says, write the systems of equations given by the graph below. So all we're doing is figuring out the equations for 2 lines. And so to figure out the equations, we want to find the slope. And we want to find the y-intercept, which is b. And we can write it in the format y equals mx plus b. So let's take a look. Well, notice that both lines have the same y-intercept right there at 3. So we know it's going to say plus 3 at the end because that's your y-intercept. And so the other thing we're going to need is the slope of the 2 lines. So let's take a look. This graph is kind of small, but I think we can figure it out. Let's start with line A. This is line A right here. So we can go up 1 and over 2. Up 1 and over 2. So it looks like it has a slope of 1/2. So we can say 1/2 x, and there's your equation, y equals 1/2 x plus 3. Now, the slope on line B is maybe a little trickier because these boxes are so small, but it looks to me like this is the pretty point right here on 6. So we're going up 1 and over 6. So that would be 1/6 x plus 3. Now, how many solutions are there for this system of linear equations? Well, they have different slopes, and it's obvious from the picture they intersect only one place. There's only one solution. And how about we name that solution as a coordinate pair? It's right here, and the solution is 0, 3. Bada bing, bada boom. And there you go. Now that lesson should be pretty basic for you because you've been writing equations from tables and from graphs for several weeks now. So it's going to get a little harder as we move forward because we're going to start solving these solutions. And that's what can be a little bit more tricky. But I think you guys can do a great job at writing the equations. Okay, so we'll see you in class, and good luck on your homework. Okay, bye.